Strings are objects that are what they sound like. They're one-dimensional objects, and therefore they can exist in a multitude of states. They can be straight or they can be vibrating like the strings in a violin. For low frequencies they can have few vibrational nodes, and for high frequencies they can have many vibrations, and each state of the string corresponds to a different elementary particle.
Now, one of the early ideas from the 1970s was that, in fact, you could spread this charge out along a little piece of string. I think it's a kind of a interesting idea, but it has taken decades of the best minds and mathematicians and physicists working on this to realize that there may be no solution which allows you to describe particles in terms of little waving bits of string, whether they're open or closed on themselves or what have you. Now they've gone into higher dimensional representations of particles, so-called M theory, which uses like 11 or 10 dimensions to describe the world that we have. And in that theory, and this is what string theory has evolved to in this decade now, they have now realized that yes, there are solutions that could give us the world we know and love, but there are 10 to some huge number, like 500, 10 to the 500th different possible solutions to string theory. And now the challenge is to figure out, is there some principle that could allow us to select out the one solution out of 10 to the 500th which describes our world. So string theory is at a bit of an impasse, but to solve this particular problem. And I don't know what the future holds for string theory at all. I think we need more guidance from experiment. We need to know more about the nature of the world that we're in to restrict the space of possible explanations from string theory or whatever other theory lies beyond what we have now.
A massive particle could be vibrating not just in our dimensions but inside extra dimensions. This we would describe as, and the different modes of vibration of the particle inside the extra dimensions could be described as ordinary particles but of different mass, a variety of ordinary particles of different mass. So in fact the vibration of particles inside the extra dimensions give you a multiplicity of particles inside our dimensions.
It could be that the mass, the intrinsic mass of particles is related to even smaller constituents that they might have. If you take all of the protons and neutrons that you need to assemble a carbon nucleus, and you need 6 protons and 6 neutrons, and you measure their mass, and now you put them together into a carbon nucleus, you find that the mass of the carbon nucleus is slightly less than the mass of the 6 protons and 6 neutrons that you had to begin with. When those particles glom together into the nucleus, energy is given off in the form of gamma rays or whatever. This is the basis of nuclear energy, in fact, right? Is incredible amounts of energy. Now imagine, scale this up to hundreds of times more energy than we have in nuclear energy. And you can imagine that, well, maybe an electron is a very tightly bound, or the most tightly bound state of 2 other particles. And that the heavier versions, the muon and the tau, which are charged leptons like the electron, are just excitations of the electron itself. That's not impossible, I suppose. You could come up with a theory that does that.